Process of adding a total connect data stream begins the same way you would connect to an API. You want to navigate to Connected Mix, and once you're in the Data Streams List tab, select Create New. Instead of selecting one of the API connectors below, you want to select this Total Connect tile on the left. Like we did earlier, we'll want to name the file so it can easily be found and referenced later. Next, you can either select Browse to upload your data, or simply drag and drop it directly onto the page. As you can see, the data upload process is divided into 3 steps: Preview Source, Map to Model, and Advanced Settings. Right now, we're at the first step, which is Preview Source. This shows you the first 100 rows of the data you're uploading in a table format. You can use the highlight tool to get a sense of the makeup of your data. For example, you can highlight date fields, text fields, which are dimensions, and number fields, which are measurements. You can also apply transformers to your data here using this Edit Transformers button. We're not going to cover transformers today, but we do have knowledge base articles if you're interested in learning more. One thing I will note is that you can apply transformers on this screen, and then on the same screen, preview how they will affect your data before it's uploaded into intelligence. This is helpful in that if a transformer isn't working as intended, you can go back and fix it before your data is uploaded. We've looked at our file, and we've determined that it's being input into the system correctly. So we're done with this step, and it's time to move on to mapping. So once we click Next, as you can see here, intelligence is analyzing the file to determine which data stream type or data model is the best fit for this stream. Essentially, the platform is looking at the column headers and recommending a data model that most closely matches the data in your file. So it's now analyzed this file and is recommending the ads data model for this stream. So on the mapping screen, we have fields on the left and fields on the right. On the left-hand side of the screen are all the external fields from the file I just uploaded. On the right, we have the dimensions and measurements for the ads data model. There are a lot of available fields here, and you can expand or collapse by entity and view all the available fields to map to. So let's say you felt that ads was not the correct data model for the stream. You can go in and manually change the data stream type or data model. To do that, just click these arrows on the right, and you'll see all the different data models available. You can scroll down and find the best data model for your data. You'll notice there's an indicator on the bottom right of how close a match your data is for this particular data model. So while search keywords may be a suitable data model for this data, as we scroll down, we can see that there is less confidence in many of the other options. On the top right of each tile, you can click more details to see additional information about that particular data model, including the main entity and how it relates to the other entities. To switch to a different data model, just click on the option you want, and you'll get a warning letting you know that any custom mapping you may have done will be lost. So any customizations or formulas applied before changing the data model would have to be redone in the new data model. To avoid having to redo your work, you want to select the right data model before you begin manually mapping your file. You can also select a previously made generic data model for your data, or create a new one if your data doesn't fit into any of the predefined models. To do this, just click this blue plus button at the top. However, I'm happy with my current ads data model, so I'm going to leave everything as is. In the middle of my screen, we have all the fields that are already mapped. As you might have noticed, every field from my source file was automatically mapped to an intelligence data model field. This is because the file I uploaded had recognizable columns. Intelligence is familiar with fields like campaign name, placement ID, impressions, clicks, and so on. As a result, these fields are auto-mapped for me. However, even when a file is automatically mapped, it's important to QA your data to ensure that the mapping was done the way you would have done it yourself. Any changes to the mapping should be done before moving forward. For example, we see that intelligence mapped campaign category to the campaign category data model field. However, maybe I don't need that field in intelligence. If that's the case, I can just unmap this by clicking over this connection and clicking on map. You'll see the field in white now on the left. Conversely, if I wanted to map a field that did not get auto-mapped, I can do that by clicking on the source file field on the left and then finding a data model field on the right to map it to. So I'll go back and map this to campaign category and hit apply. If you aren't happy with the automatic mapping, you can unmap all fields by clicking these three dots over here and selecting Unmap All Fields. You can then begin mapping manually by either selecting a source field or a data model field. If you make any errors throughout the mapping process, you can hit the Undo button, and as we can see, data is now remapped. Another thing to note is that for files with large amounts of columns, the screen can be difficult to manage. What you can do is use this Collapse All button. This collapses all fields so that you can focus on mapping your entities one by one. You can also click on this magnifying glass icon at the top to search for specific entities, and it will hide everything else. Now I want to show you how to use a formula when mapping your file. So if we take a look at the source file, you can see that our campaign name looks to be a concatenation of several different fields, including campaign key, year, quarter, company name, and so on, separated by an underscore. What I can do is pull any of these out and use it as a separate dimension. So let's assume this first set of digits that we see here is a campaign billing code. On this left-hand side of the screen, I can start typing in the name of the new dimension I want to map to. In this case, campaign billing code. I've selected Use as Formula, so I can use a formula to map this to a data model field. Now on the right, I want to find a field to map it to, so I'm going to select campaign billing code or search for it. Now I need to use a formula to extract the campaign billing code from the campaign name. I can write a formula on this screen that will get me the results I'm looking for. However, let's say I don't remember the syntax for the extract function. What I can do is click on this formula editor button, which opens up a screen that shows us all available formulas and functions alongside both external and data model fields. You can either browse to find the function that best fits your needs or search for it directly. In this case, I know that I need to use the extract function, so I'm going to type it in and search for it. So now I've double-clicked on this, which gives me the function and the syntax. And more information can be found in the lower right-hand corner if you need it. So in order for this function to work, I need three things. I need text, I need delimiter, and the position. The text is simply the text we are extracting from. In this case, it's the campaign name from the source file. What I can do here is add that CSV field right into here by typing CSV and looking for the campaign name field. The delimiter is what separates the unique items in the campaign name. In this case, it's an underscore, so we'll want to place that there in single quotes. Finally, the position is the position in the campaign name where the campaign billing code could be found. As we can see in our file, it's in the first position. Intelligence begins counting at 0, so we'll want to put 0 as our position. Now, our formula looks good, but it's probably best to test it before applying it to our data stream. The first thing you can do is use the Validate Syntax feature. This does just what the name says. It validates that your syntax is written correctly. Any mistakes will be highlighted in red at the bottom for you to adjust. And once you fix this, you should see a message saying no syntax errors detected. What you can do next is further test your formula by clicking the Evaluate button. This will allow you to actually test that your function is doing what you want it to do. In this case, I wanted to pull the billing code from the campaign name. To test, I'll grab a campaign name, paste it in, and see if it's extracting the code as I want it to. As I can see, it's properly extracting that field, so our function was written successfully. Now that we've verified everything, we can hit apply. As we can see, we now have a new custom field mapped under the campaign entity. You can actually preview your mapping and verify everything looks the way you want it to. Our new campaign billing code column is here as expected, with the codes pulled from the campaign name. Another thing to be aware of on this screen are the field properties. For example, in the ads data model, the main entity is media buy. This is indicated by the main entity icon, while all of the other keys will be indicated by this key icon. To see more data model field properties, you can click on the icon present next to all fields. This will pull up the model field property screen, which has some additional information, including the display name, the original name, which is not editable, and field type. The display name can be changed, which is how it will display in any reports, visualizations, and tables throughout your workspace, not just for your user or data stream. The type corresponds to the type of data present in the field. So a dimension would be text, measurements would be a number, and so on. One thing to remember is that data model fields have a character length limit. So if you're uploading a link or image, make sure it's being mapped to a field that can accommodate that length. Otherwise, your image paths or links may get cut off. Once you've finished mapping and making all your customizations, you want to validate your work, which can alert you to any potential mapping errors or irregularities. You can do this by clicking the Validate button. If there are any mapping errors, you will be alerted to them so that you can rectify them before you save this new data stream. So now that we're done with our mapping, you can either create your stream or move on to the Advanced tab. Before we move on, let's jump back into the slides for a minute. The Advanced screen in Total Connect is where you would set up an automated data refresh. So once you've mapped everything and are happy with your data stream, you can schedule data refreshes so you don't have to manually upload a file into the stream every day or week. So let's go back to the platform and take a look. So in the Advanced screen, we're going to go to Automate Data Refresh. Once you've navigated over to this section, we'll click the pen button like we just did to edit these options. Now there are two ways you can schedule a Total Connect. You can pull data, which involves having intelligence go into the data source and fetch the data, or you can push data from the source directly into our platform. If you'll be pulling data, you want to select Import Data, we have here, and choose a technical vendor from the list. There are many options here, including Google Drive, SFTP, Dropbox, and more. If you don't want to retrieve data, you can push, which gives you the option to schedule an email to export from the source and deliver to your stream. To do this, you'll need to grab the unique email address assigned to every data stream, which can be found here. This is the same process with SFTP. Every stream gets unique SFTP credentials that you can use to send data into our platform on the schedule you choose.